Okay, so we're gonna go over Shannon's law. So, if you wanna if you were working with a multiplexer and you want to know what these inputs should be, you could and you are given the output, then using Shannon's law would be really useful to figure this out. So first thing you're gonna do is choose a selector. So let's choose W1 to be our selector. Okay, so this is pretty much how it's gonna work. We're gonna have we can set up our equation to be in the following. Okay, and inside here there'll be some kind of form of this question. So we're gonna declare that for W1, we're gonna declare that the equation inside W1 is gonna be 1 and W1 naught is gonna be 0. Okay, so from here we see this would cancel out and we yield out W2, W3 naught. So we put that into here. Okay, now, so we got this bit done. For the other bit, we pretty much are going to declare that W1 naught is equal to 0 and W1 naught is equal to 1 and W1 is equal to 0. Okay, so we see this yields the following: W3 plus W2 W3 naught. Okay, and this is the same thing as W3 plus W2. Okay, so in here you can either write down W3 plus W2 W3 naught. You can either put that one in, or you could just put down W3 plus W2. Okay, because this and this are actually equal to each other. So pretty much if you could put the hold on, you could put W1 as your selector in here, and then this side of the circuit will be W2 W3 naught, and this side will be, wait, hold on, sorry, this is 0 1. So sorry, this side of the circuit will be the one that's being times by W1 naught. So it'll be W3 plus W2, and this side it'll be W2 W3 naught. And then you could do Shannon's rule again for this one to see, because obviously this is probably connected to another multiplexer because um of how this is arranged, because there's not a singular output, or it could be connected to a logic gate where we have something like this, like an uh, OR gate. Okay, and this one, it can be connected to an AND gate where we have W2 being fed into here, and then the NOT of W3 being fed into here. Okay, but yeah, but if you want to add like another multiplexer and you want to know what the input should be, you use Shannon's rule.